In 2014, divers dropped into a flooded sinkhole in southwestern Madagascar and switched on their lights about 40 meters down. The floor was covered in bone, not scattered fragments, whole skeletons lying where the animals fell. A lemur built like a small gorilla, a bird that could not fly and weighed as much as a person, a crocodile with horns above its eyes. Every one of them is extinct. Most of them were still alive 1,000 years ago. Avon Cave is one site. The island has produced 24 more finds of the same kind, and the thing they have in common is not the strangeness. It is the timing. Madagascar sits about 400 kilometers off the coast of Mozambique. It is the fourth largest island in the world, roughly the size of France, and it has been cut off from every other landmass for something close to 88 million years. That isolation is why the island matters to science. Most places on Earth are a mixture, species arriving, leaving, interbreeding, competing with whatever wandered in last. Madagascar has been running a much cleaner experiment. A small number of things got there. Almost nothing else ever did. And then evolution was left alone with the results for a very long time. What comes out of that experiment is a list of organisms and objects that, on paper, should not be there. 25 of them in order, starting 88 million years ago, and ending with something nobody has explained yet. If you want more films built this way, subscribe. 1. A mammal with a skeleton nobody can classify. In 2020, a team led by David Krause published a near-complete skeleton from Madagascar's Maivarano Formation, about 66 million years old. They named it Adelatherium hui. The informal translation of the genus is crazy beast. It earned that. The animal is roughly the size of a badger, which for a Mesozoic mammal is already large. But the specifics are what unsettled the field. Its snout is riddled with more nerve and blood vessel openings than any known mammal, living or extinct. Its vertebral count is wrong. Its leg bones combine features that, everywhere else in the mammal record, do not occur together. Krause's team described the skeleton as a mosaic, some traits primitive, some derived, none of them arranged in a way that matches another animal. Their explanation was geographic. Adelatherium belongs to a group called Gondwanatherians, and it evolved on a landmass that had already been isolated for tens of millions of years. Long-term insularity. In their phrasing, the rules got loose because nothing was enforcing them. One skeleton is all we have. 2. A frog with the wrong relatives. In 2008, Susan Evans, Mark Jones, and David Krause described Beelzebufo ampinga from the same formation, a heavily armored frog with a skull built like a helmet, reconstructed at up to about 40 centimeters. The size was not the finding. The finding was the family tree. Beelzebufo's closest relatives are ceratophrine frogs, the horned frogs of South America. Not Africa, which is far closer. That distribution only makes sense if Madagascar, Antarctica, and South America were still connected, or nearly connected, late enough in the Cretaceous for the lineage to spread. It has been used since as evidence in a long argument about how Gondwana actually came apart. 3. Crocodile that ate plants, Simosuchus clarkii, described in Nature in 2000. Blunt, almost pug-like snout, body armor running down the back and tail, short limbs, and a mouth full of leaf-shaped multi-cusped teeth that no meat-eating crocodiliform has. The dentition is the argument for herbivory. It is an inference from tooth shape, rather than a direct observation, but it is a strong one. Simosuchus was a small, armored, plant-eating relative of crocodiles, living alongside dinosaurs, on an island that had already begun to write its own rules. 4. The island tilted and its rivers ran backwards. Madagascar did not separate from Africa in one event. It separated twice from two different directions. The first rift, beginning around 170 million years ago, pulled it away from Africa. The land tilted eastward, and the rivers drained east. The second, around 90 million years ago, tore India away from Madagascar's eastern flank, driven by a hotspot that also produced an enormous outpouring of basalt, radiometrically dated to 87.6 million years. give or take 600,000. A 2025 study in Science Advances, led by Romano Clementucci, argues that this second rift reversed the island's tilt. The high ground shifted, the drainage reorganized. The rivers that had run east now ran west, and a steep escarpment formed along the eastern edge, the wall that today catches the moisture and gives Madagascar a rainforest on one side and a spiny desert on the other. Their argument is that this reinspeciation bump populations kept getting separated by shifting drainage, even to this model. It is one team's model published recently, and it will be tested. But the physical geography it describes is not in dispute. You can see the escarpment from orbit. 5. A forest made of stone. The Singi de Bemaraha is a field of limestone blades, some over 40 meters tall, packed so tightly that in places there is no walkable ground between them. The word Singi is often glossed as referring to ground you cannot walk on barefoot. The rock itself is Jurassic, roughly 170 million years old, laid down as a coastal barrier and lagoon system when this was seafloor. Rainwater, slightly acidic, has been cutting down into it along its natural joints ever since. Some of the passages inside began as flooded caves and were only exposed when the roof came off. Here is the honest limit. There is no absolute date for when the pinnacles reached their present form. The age of the limestone is well established. The timing of the carving is not. Anyone who tells you that Singi formed a specific number of million years ago is going past the evidence. That is the stage. Old rock, twice tilted, cut off early. Now the filter. Because the strangest thing about Madagascar's living animals is not any individual species. It is the list of what never arrived. 6. A reptile you can lose in your palm. Brucusha nana, described in 2021. The male has a snout-to-vent length of 13.5 millimeters and a total length of about 22 millimeters. It sits comfortably on a fingertip. It has been widely reported as the smallest reptile on Earth, and that claim needs a footnote. The record depends on whether you measure males or females, and the females of this species are larger than some rivals' males. What is not in dispute is that a functioning vertebrate with eyes, a spine, a nervous system, a full reproductive apparatus is operating at that scale in leaf litter in northern Madagascar and was unknown to science until this decade. 7. An animal that spends most of its life as an egg-laboreds chameleon, Furcifer labordi, hatches in November. It grows fast, breeds, and is dead by about February or March. Carson and colleagues documented this in PNAS in 2008. An active post-hatching lifespan of roughly 4 to 5 months, the shortest known for any four-limbed vertebrate. The eggs then sit in the ground for 8 or 9 months developing. For most of any given year, the entire species exists only as buried eggs. There is no adult population. There is an annual one. 8. A primate that hunts by knocking the IA is a lemur, though almost nobody guesses that on sight. It has rodent-like incisors that never stop growing, ears it can rotate independently, and a third finger that is elongated, thinned, and mounted on a ball-and-socked joint finger. The only such joint in a primate finger. It uses that finger to tap along a branch, several times a second, and listens to the echo through those ears. When the sound changes, it gnaws through the wood and extracts the grub with the same finger. Percussive foraging. Elsewhere in the world, woodpeckers do this job. Then in 2019, Adam Hartstone-Rose's team dissected IA forelimbs and found something that had been missed for 2 centuries. A pseudo-thumb. A small extra digit with its own cartilage, its own 3 muscles, and its own tendon, probably compensating for a hand so specialized for tapping that gripping had become difficult. 200 years of anatomical study, and the animal still had a finger nobody had counted. In parts of Madagascar, the IA is subject to fady, customary prohibitions, in some regions treating the animal as an ill omen. That is oral tradition and local practice, and it belongs to the communities who hold it. It is not a biological claim, and it should not be repeated as one. 9. A mammal that plays itself like an instrument, the lowland streaked tenrec, has a patch of specialized quills on its back. It can rub them together to produce a high-frequency sound, apparently used to keep family groups in contact in dense vegetation. Crickets do this. Some spiders do this. Among mammals, it is known only from this animal. Tenrecs are the clearest illustration of the filter. One colonization, somewhere between 25 and 42 million years ago, produced a radiation that now includes forms resembling hedgehogs, shrews, moles, and otters, none of which are closely related to any of those. 10. Fish with no eyes and no pigment. In the limestone aquifers of the southwest, in water that has never seen daylight, there are fish. Typhleotris mararibe, described in 2012, is blind and unpigmented. So are its relatives in the northern karst. The karst systems these fish live in are barely mapped. Ankara alone has over 100 kilometers of surveyed passage, among the longest cave systems in Africa, and surveying is not finished. 11. Every native carnivore descends from one crossing. The fossa is Madagascar's largest living predator, around 1.5 meters nose to tail, semi-arboreal, with retractable claws and reversible ankles. It looks like the result of a cat and a mongoose argument. In 2003, Ann Yoder and colleagues showed in Nature that the fossa, the Falanuk, the Phonoloka, and the Malagasy mongooses all descend from a single carnivoran ancestor that arrived somewhere between 19 and 26 million years ago. One animal, or one small group, crossed the Mozambique Channel. Every native carnivore role on the island was then filled by its descendants. 12. The baobabs came from here. There are 8 baobab species. 6 live only in Madagascar. 1 is in mainland Africa. 1 is in northwestern Australia. The obvious reading is that baobabs are African and some reached Madagascar. In 2024, a genomic study in Nature led by Junnanwan, all 8 lineages trace back to a Madagascar origin. The African and Australian species are the emigrants, established by separate long-distance dispersal events. The tree that has become the visual shorthand for the African savanna started on the island. 13. The animals that never came, now the absence. Madagascar has no native monkeys, no apes, no big cats, no dogs, no bears, no elephants, no rhinos, no zebra, no antelope, no hoofed mammals at all. Only 4 orders of native non-flying land mammals ever established. The lemur lineage, the tenrecs, that one carnivoran founder, and 1 group of rodents. In 2010, Jason Alley and Matthew Huber published the leading explanation in Nature. They modeled Indian Ocean surface currents in the Paleogene and found something the modern map hides. The currents used to run the other way, west to east, from Africa toward Madagascar. A tree torn loose in a Mozambican flood could be carried to the island in a few weeks, survivable for a small animal that can slow its metabolism. Then, in the mid-Miocene, the currents reversed to their present configuration. Roughly 79% of Madagascar's terrestrial colonizers had arrived before that point. Afterwards, the door was effectively shut, and monkeys, cats, and antelope had not yet radiated into a position to walk through it. The filter was not selective about species. It was selective about timing and about body size, and about which animals could survive weeks at sea without water. That is not a settled story in every detail. A 2018 fossil study by Greg Gunnell and colleagues argued that the IAE lineage split from other lemurs in Africa around 41 million years ago, which would mean at least 2 separate lemur crossings, the later one possibly as recent as 20 million years ago. The molecular clock studies and the fossil evidence do not currently agree on this, and both camps are still publishing. So, an old island filtered arrivals empty rolls. What fills empty rolls is size. 14. The graveyard under the water table back to the cave. In 2014, a team led by the cave diver Philip Lehman and the primatologist Alfred Rosenberger dove Avon Cave and Matoho Cave inside Simonam-Petsotsa National Park. The results were published in the Journal of Human Evolution in 2015. What makes the deposit valuable is not quantity. It is condition. On land, subfossil bone gets trampled, gnawed, weathered, and scattered. Underwater, In still, cool, mineral-rich water, it does not. The team recovered articulated skeletons with very little post-mortem breakage, extinct lemurs including pie lemur and Mesopropithecus, elephant birds, turtles, crocodiles, rodents, and the extinct giant fossa, Cryptoproctus spelaea. The animals in that cave died across a window running from roughly 2,000 to 500 years ago. In geological terms, that is not the deep past. It is the period during which people were building trading towns on the same island. 15. A lemur the size of a gorilla, Archaeoindris fontoinanti, is the largest lemur ever found, and its published mass has been falling for 35 years. In 1990, William Jungers estimated around 230 to 244 kilograms. In 1995, Laurie Godfrey revised it to about 197. In 2008, Jungers and colleagues, using femoral cortical area, put it at roughly 161 kilograms, with a range of 150 to 188. That downward drift is worth pausing on, because it is what a functioning science looks like from the outside. The animal did not shrink. The method improved. And in 2025, another revision of extinct lemur masses was published, which means the number in this script will probably be out of date before the channel is a year old. At least 17 species of large lemur went extinct in the Holocene. Not one of them survived. Every giant lemur is gone. Every surviving lemur is small. Radiocarbon dates put Archaeoindris material at around 2,300 to 2,700 years before present. It was alive, in other words, within the window where the human arrival debate is happening. 16. The largest egg any animal has ever laid. Elephant birds. Flightless, up to about 3 meters tall, with the largest specimens estimated around 800 kilograms. Their eggs are the more striking object. Volume between roughly 5.5 and 13 liters. Around 26 to 40 centimeters long. Shell about 3.3 millimeters thick. Egg mass around 10.5 kilograms, the largest egg produced by any known amniote, including every dinosaur we have eggs for. 2 cautions. First, the figure of 1,000 kilograms circulates widely and sits at the far edge of what the primary literature supports. The safer range is 275 to 800. Second, in 2018, Hansford and Turvey split the family into 3 genera and named Varroa titan as the largest bird ever. In 2023, Alicia Greeley's team extracted DNA from fossil eggshell and found very little genetic separation among the large-bodied specimens, consistent with Varroa being large female Epiornis maximus rather than a separate genus. That has not been formally resolved. The same study did find something new, a previously unrecognized northern lineage, much smaller, around 230 kilograms, that diverged over 1 million years ago and was sitting unnoticed in fragments of eggshell. 17. Its closest living relative weighs 4 kilograms. The obvious guess for the elephant bird's nearest surviving relative is the ostrich. Same body plan, same continent-adjacent geography, same flightless retite group. In 2014, Kieran Mitchell's team sequenced ancient DNA from elephant bird bone and published the answer in Science. The closest living relative is the kiwi, a nocturnal, roughly chicken-sized bird in New Zealand, about 11,000 kilometers away. The 2 lineages are estimated to have diverged around 54 million years ago, which means flightlessness in retites did not come from a single flightless ancestor riding the continents apart. It evolved repeatedly, in birds that could still fly when they arrived. 18. A crocodile with horns, reclassified by its own genome Voi robustus, had bony protrusions above its eyes. For most of the 20th century, anatomists grouped it with the dwarf crocodiles based on skull shape. In 2021, Ivan Hekala's team recovered a mitochondrial genome from Voi bone and published it in Communications Biology. The morphology had misled everyone. Voi is a sister lineage to Crocodilus, the true crocodiles. Direct radiocarbon dates on 2 specimens, 1,450 and 1,380 years before present. It was alive in the 7th century of the Common Era. The Nile crocodiles in Madagascar's rivers today are a separate later arrival, and no evidence of hybridization between the two was found. Competitive replacement is a reasonable hypothesis. It is not proven. 19. Species identified from one bone. In 2023, a team led by Christian Kalemeyer published a new extinct giant tortoise in Science Advances, Astrochelys rogerberi. The entire species is known from a single tibia. Ancient DNA from that one bone placed it as sister to the living plowshare tortoise, with a divergence around 15.4 million years ago. The bone dates to between 1,262 and 1,069 calibrated years before present. The same study settled an older question, confirming that Aldebrachles abrupta and Aldebrachles grandidieri are genuinely two species rather than one. An animal that existed for millions of years, vanished about 1,000 years ago, and was recognized as a distinct species only 3 years ago, from one-legged bone in a drawer. Everything so far has a cause that runs through people. So the obvious question is when people got there, and that is where the evidence stops cooperating. 20. The language points to Borneo Malagasy is not an African language. It is Austronesian, and its closest known relative is Ma'an-Yan, a Burrito group language spoken in southern Borneo, about 7,000 kilometers east across open ocean. This has been established linguistically for a long time, and it is one of the more remarkable facts in historical linguistics. But the genetics complicate it. In 2016, Pradiptajati Kusuma's team found that the distinctive Ma'an-Yan genomic component reaches only 2 to 15% in Malagasy populations, while running at 80 to 95% among the Ma'an-Yan themselves. The language and the ancestry point at different populations. The current explanation is that the voyagers were burrito-related people who had already mixed into the Malay and Javanese trading world before they left. 21. Rice, mung bean, cotton. For a long time, this was a linguistic and genetic argument with no archaeology behind it. Then, in 2016, Alison Crowther's team analyzed more than 2,500 archaeobotanical remains from 18 sites across East Africa, Madagascar, and the Comoros. Rice, mung bean, and Asian cotton turned up concentrated in Madagascar and the Comoros, and were largely absent from the mainland East African sites, dating to roughly the 8th to 10th centuries. That is the first direct archaeological signature of the Austronesian expansion into the Western Indian Ocean. Not a language, not a genome. Carbonized seeds. 22. Roughly 30 women. In 2012, Murray Cox and colleagues compared mitochondrial DNA from around 300 Malagasy and 3,000 Indonesian individuals and ran coalescent simulations to ask how small the founding maternal population could have been. The estimate came back at approximately 30 women. Two things to be precise about. That is a statistical estimate from a model, not a head count, and it comes from modern DNA in living populations. There is still no published ancient human DNA study from Malagasy archaeological remains. Every claim about Malagasy origins in this section is reconstructed from people alive today. 23. The bone that will not settle. In 2018, James Hansford's team published cut marks on elephant bird leg bones from Christmas River in central Madagascar. The marks were interpreted as butchery. The bones were AMS dated at 3 independent laboratories and came back at about 10,500 years before present. If that reading is right, people were on Madagascar roughly 8,000 years earlier than the archaeology had shown. Later that same year, Athol Anderson, Jeffrey Clark, and colleagues published a response in PLOS 1. They examined 1,787 megafaunal bones, around 40 times the sample of every previous cut mark study combined. Marks appeared on between 0.11 and 0.137% of the ancient bones, against 9% of modern comparison material. Their conclusion was that the marks are taphonomic, root etching, sediment abrasion, excavation damage, and that human colonization dates to about 1300 to 1100 years ago. In 2019, Christina Douglas and colleagues screened 199 radiocarbon dates from 64 sites and produced the most careful position available. Human presence is well supported from around 2,000 years ago. The Christmas River dates are real dates on real bone, but they sit alone, with no associated tools, hearths, or settlement traces anywhere near them. So the honest statement is layered. Secure human presence, about 2,000 years. Contested earlier presence, possibly 4,000, possibly 10,500. The demographic wave that produced most living Malagasy people. 7th to 10th centuries. Nobody has resolved this. As of 2026, no new fieldwork has moved it. Two things on the island still have no agreed explanation. 24. The scars that came before us. Across the Central Highlands there are erosion features called lavaca, steep amphitheaters gouged into the hillsides, sometimes hundreds of meters across. They are the reason so much Malagasy soil is visibly red, and they have been used for decades as the standard illustration of human-caused environmental damage. In 2024, a study in Science Advances led by Sean Cox dated lavaca formation directly. Some are 20 to 25,000 years old. They predate any human presence on the island by a wide margin under every proposed arrival date. The study also found no spatial correlation between lavaca and deforestation. This does not mean people have had no effect. Other work, including Liasbet Brosens and colleagues in 2021, finds both climate and human drivers behind recent acceleration. But the founding claim that lavaca are a human creation does not survive the dating. It is a useful example of how a compelling visual can carry a wrong explanation for a long time. 25. The window which brings us to the thing all of this has been circling. Between roughly 700 and 1000 of the Common Era, Madagascar lost almost everything large. All 17+ giant lemur species, the elephant birds, the dwarf hippos, 2, possibly 3 species of giant tortoise, Voi robustus, the giant fossa, not staggered across millennia, compressed. The obvious suspect is drought. That was checked. Stalagmite records show these animals had survived earlier arid episodes that were more severe than the one they died during. The current leading model came out of work by Christina Douglas, Laurie Godfrey, Nick Scroxton, Stephen Burns, and colleagues, published in the Journal of Human Evolution in 2019. The subsistence shift hypothesis. Their argument is that the trigger was not human arrival but a change in what humans were doing, shift from low-density foraging to herding and farming. Roughly between 700 and 1000 of the Common Era, peaking around 750 to 850. 2022, Sean Hickson's team tested it in the field at coastal ponds in southwestern Madagascar. They found cut-marked pygmy hippo, giant tortoise, and elephant bird bone in deposits that also contained a sharp rise in charcoal, and the first bones of introduced zebu and dogs. All in the same layers, all around 1,000 years ago. So the evidence points at land use rather than hunting, and at a date rather than an arrival, which leaves a gap that nobody has closed. If people were present for 2,000 years, or 4,000, or 10,000, the megafauna coexisted with them for most of that time, and then stopped. Whatever changed, it was not that humans showed up. It is that they changed what they did. Back to Avon Cave. The skeletons on that floor are complete because they fell into still water and were left alone. They are recent because the animals that made them were alive within the last 2,000 years. And they are all in one deposit. Because the extinctions did not happen one at a time across the ages, they happened close together, near the end. That is the answer to the question the cave poses, as far as the evidence currently allows. Not a mystery about strange animals. A record of a specific interval, a few hundred years wide, when a filtered island that had been assembling its own biology for 88 million years lost the largest half of it. What is still open, exactly, when people first stood on that island, and whether the earliest cut marks are tools or sediment. Both of those questions rest on physical objects that already exist: bones in museum drawers, dates in laboratory reports, sediment in cores nobody has finished analyzing. They are not unanswerable. They are unanswered. 40 meters down, a lemur skeleton lies on a cave floor in the dark, arranged more or less as it fell. It has been there for about 1,000 years. It was found 12 years ago. Most of Madagascar's caves have never been dived.